A function can be defined as y of x is equal to x squared plus 2x plus 1. Here we call x an independent variable. And as we change the value of x, the value of y will change as well. So the value of y is a function of the value of x and depends on it. So then we will call y the dependent variable. And when we take the derivative of y with respect to x, this means that we want to know how y changes as we change the value of x. So we call the variable in the numerator the dependent variable, and the one in the denominator the independent variable. And we always take the derivative of the dependent variable with respect to the independent variable. And whenever in a differential equation we only have one independent variable, we call it an ordinary differential equation. ODE is a differential equation that, for example, we have x as dependent variable and t as independent variable. And also we can have several dependent variables. For example, in here we have x and y as dependent variables, and the independent variable is only t. So whenever we have only one independent variable, we call it ODE, or ordinary differential equation. And whenever we have multiple independent variables, like in this example, we call it a partial differential equation, or PDE. And note that here for the ordinary differential equation, we use d for x and y, and here we use del. That's because here in the ordinary differential equation, a function, the variable x is only a function of t, and also y is only a function of t. So when we want to take the derivative of x and y with respect to the independent variable, which is t in this example, this will be a total derivative. So we write d. However, in the other example for PDE, we have the function u, the variable u, which is a function of both x and y. So when we want to write the derivative of u with respect to x, since u is a function of two variables, so we need to write the partial derivative and not the total derivative. So delta is the notation for the partial derivatives. So the difference between ODE and PDE is that in ODEs, we only have one independent variable, and in PDEs, we can have several different independent variables. Ordinary derivatives can be written using different notations. And in here, we will go through 4 different notations that we have. The first one is called the Leibniz notation, where we show the derivatives as fractions. And the second type is the prime notation, where we show the derivatives with primes. Single prime denotes the first order derivative. Double prime is the second order derivative. Triple prime is the third order derivative, and so on and so forth. Then we have Newton's dot notation, and this is usually used to denote derivatives with respect to time t. For example, when we write s and double dot on top of it is equal to minus 32, this actually means that we have this differential equation in the Leibniz notation. And the last notation is called subscript notation. And in this type of notation, we write the independent variable as the subscript. So these 3 are different notations to show dy over dx, y double prime, and the third derivative of y with respect to x. We can classify a differential equation by its order. And the order of a differential equation, ODE or PDE, is the order of the highest derivative in the equation. For example, this term is the second order. This term is the first order derivative that goes to the power of 3. And this term y is the zeroth order derivative. So in this differential equation, the highest derivative is second derivative. So we call this one a second order differential equation. And another example for partial differential equation or PDEs can be where here this term is the fourth order derivative and this one is the second order derivative. And in here, the highest order of the derivative is 4. This will be fourth order differential equation. And note that here we had only one independent variable, so this will be ODE. And here we have two different independent variables, so this will be a PDE. We can also classify the differential equations by linearity. Let's say that we have an nth order ordinary differential equation. We will call this differential equation linear in y if all the derivatives goes to the power of 1 or b of the first degree, and also all the coefficients be a function of the independent variable or x. And a nonlinear ordinary differential equation is simply one that is not linear. So there are two characteristics of a linear ordinary differential equation. The first one is that all the dependent variable derivatives are of degree 1, and all the coefficients depend at most on the independent variable. When we solve a differential equation, we will end up having some constants in the solution. When we solve a first order differential equation, the solution will have one constant, and it's called a one parameter family of solutions. So if this is the differential equation that we have, and it's first order, then we will end up having a solution as a function of x, y, and a constant c. And we will call this one parameter family of solutions. And when we're solving an nth order differential equation, the solution will be an n parameter family of solution. So depending on what value we choose for the constant, a differential equation can have an infinite number of solutions. And a solution that is free of arbitrary parameters is called a particular solution. We can always find these constants if we have initial values for our differential equation, and we call those types of differential equation initial value problems. When an nth order derivative differential equation is given, then we will need n initial conditions to be able to find the particular solution. And we call these initial conditions.